The dew point is the temperature at which the air would be completely saturated with water, or 100% humidity. How can delta, or the triangle, be used to represent the change in dew point with respect to the change in height? So specifically, dew point respect to the change in height. Use the data from the balloon problem, calculate the average rate of change of the dew point with the respect of height from t equals 0 to 360. So in this situation here, I have a couple of things that I'm going to deal with here. So I'm saying like the change in the dew point over the change in the height. And so when I'm dealing with this here, I'm going to use the values for each of those situations. So for the first one, for the dew point, I'm saying t equals 0 here. I guess I'll do this in a different color. T equals 0. So I'm using this information here. And then for the second one, t equals 3600, I'm using this information here. So we're saying like, what's the change in the dew point, which is all this information here, over the change in the height, which is right here, or the altitude. And so when I do this here, I'm going to talk about the dew point first. I'm saying like I'm going from 9 to negative 37. So I'm going to go ahead and say like this is my second y value, or the y2 minus y1. And then for the altitude, I have x2, which is 24,900 minus ground level, which is just 0. And so when I simplify that, what I end up getting is I'm actually just going to plug it into a calculator as opposed to just having this big fraction. But what I end up getting is about negative 0.0018. And the units in this, because dew point is like temperature in Celsius and altitude is feet, I would say degrees per foot.